All right. Hello, everyone. Welcome to another Q&A review set. Today, we will be going over the Coding Club Set 2. So this will focus on a lot of C and C++ concepts. So let's get started here. Question 1, the following program. So we have main with int ABC, ABC, and then we call the reference using the star operand, ABC. And it looks like the method itself is just a simple print statement. And we want to know what will happen if you run this. So in C, the second and third options will actually evoke the method, but the first one will not. If you look at the second one here, this is just a basic method call, so that will end up printing out go. And then again, right here, this is also a another way to evoke a method. So that's pretty straightforward. So this will end up evoking the method, the second and third line. It'll print out go twice. So the answer here will be B. All right, let's move on. Question 2, consider the following program fragment. So we have D, which is just a simple counter, and a triple nested for loop, each iterating from 1 to 30 using the variables I, j, and k. And we have if I plus j plus k modulus 3, so if the addition of all three of these variables is divisible by 3, then we will want to increment the counter. And then we're going to end up printing the counter. So they're asking us, what will the counter end up being? So one thing to keep in mind before looking at this is to understand, the very basic math rule, and that's if you add any number or any set of numbers that are all divisible by 3, the summation will always also be divisible by 3. So that's something really important to know for this one here. So let's just look at the question here. So we have all 3 loops that are the same number of times, 1 through 30. Okay, so let's write this down. So we have the outer loop that runs 30 times, and then the inner loop 30 more times, and the inner loop again 30 more times. So let's just take this one step at a time. So if we look at, let's say, the inner loop, what values of I here would be divisible by 3? In other words, if you modulus 3, will it end up 0? So let's start. Let's just go through each and every number that is divisible by 3, starting at 1. So we have 3, 6, 9, 12, 15, 18, 21, 4, 7, 30. So they're actually going to be within each set of 30, from 1 to 30, 10 numbers of I are divisible by 3. And the same is the same for J, because it's the same loop, and the same is for K. So what does this mean? So that means we have 30 times 30 times 30 possible iterations of the run, but within each 30, only 10 values of the iterator are divisible. So we have 10, so we have 30. And if you think about that, so within each set of 30, 10 are divisible, or in other words, 1/3 of each full iteration make the value divisible. So let's look at the total count for how many iterations we're going through. So that'll be 30 on the outer, 30 in the middle, and then 30 on like the very inner. So let's pull out a calculator and just calculate that real quick. So we got 30 times 30 times 30. So we got 27,000 total runs of I, J, and K. And we said earlier that for each iteration, 3 or 10 out of the 30, or 1/3 of the values make the iterator divisible by 3. And remember, if we said at the very beginning that any 3 numbers that are divisible by 3 added up will always, the sum will also always be divisible. So using that basic math rule, we can deduce that the total number out of total number, 1/3 of those iterations will ring true for this if statement. And what is that? That is 9,000. So answer here is A. All right, so let's move on to question 3 here. A data-driven machine is something that executes an instruction if the needed data is available. The physical ordering of the code does not dictate the flow of execution. Considering this following pseudocode. So we have all these pseudocode declarations. So, and then they tell us, assume Sunday and Monday are already assigned values. What is the, so we're expecting to eventually reach Saturday. Which of the following sequence is valid? So if you remember, real quick about data-driven like machine algorithms is we always, just like it says in the description, you always start at the instruction that works with the data that is available. So it's not necessarily in order. It doesn't execute in order of how it's listed, but rather in order of which things you could evaluate given you have all the right variables. So in this case, if you look at this, you have Sunday, Monday are already assigned values. So we have Sunday, we have Monday. So let's look at which of these we can use already. And that will be B. Add Sunday, Monday. Remember, we have Sunday, Monday already. So we can already evaluate B. So right off the bat, we can see that the answer is A, because A is the only answer that has B as the first operation. If you look at C here, multiply Thursday, we don't have Thursday, so we can't evaluate that yet. So it can't be B, it can't be C. And we have E right here. So this is kind of a possibility because we have Sunday. But let's look further. So let's look at the second one. It could either be BA or ED. So with BA, so after evaluating B, we can do add Monday. And once again, we can do this because we have Monday, so A is possible. But if you look at D as a second operand, at Thursday and Friday, we don't have either of those. So that therefore the answer cannot be D as well. So just by looking at the first two operations, we can deduce that the answer in this one will be A. Okay, question 4. An experimental coding language with string manipulation functions are described below. So we have start S, which just returns the first character. We have end, which returns all but the first character, and then attach, which concatenates two strings. So they want us to evaluate this pretty long statement here, where S is equal to ACBC. So let's just start off by rewriting this and in a more clear way. So we have attach, start S, and then start end, and S. Okay, so this is what we're trying to evaluate here. And then we have S, which is ACBC. So we can just start at the very end case here and just start working our way backwards. So what is end S? So end is returns all but the first character. So end S will be CBC. So let's just fill that in and replace it. And then we have end of CBC. Again, it's just everything but the first. So this will be BC. And now we have start of BC. Remember, start is the first character. So this will be B. And then start S And what is S? A, C, B, C. So start S would be A. And now we just have attach AB, and remember attach is just a simple concatenation. So attach AB equals AB. So we have A as our answer. Okay, let's move on. Question 5. An array A consists of P numbers of integers from array is 0 to array P minus 1. It is required to shift the elements of the array cyclically to the left by M places. So we can assume that M is between 1 and P minus 1. An algorithm for doing the same in linear time is presented with some incompleteness. Fill in the blanks and assume that all variables are declared. Okay, so remember, just like the previous questions, let's try our best to just start eliminating answers that cannot be true. But let's start by just looking at this incomplete algorithm. So we have a outer while loop here. And then within the while loop, we declare a temp variable, which is just whatever is at that index, and then a temp j, which is that index. And then we have another inner while loop here, where we set something in the array at j, and then we set a min. And then after this while loop, we set the array at some place equal to something, and then we increment index by something. Okay, so let's look at our options here. So 2 of the options say index is greater than min, and 2 of them say index is less than min. So let's think about the case. Let's look at A and C, where it says while index is greater than min. So remember, in the beginning, index is 0, and then min equals the size of the array. So if we have index is greater than min, this will bring false at the very first iteration. So it'll never even end up touching any of this code inside. So because of that, we know that A and C cannot be true. If remember, P is the length of the array. So P is some positive number, and index is going to start at 0. And 0 is never going to be greater than some positive integer. So A and C don't make sense. So it has to be while index is less than min in order to kickstart, the entire process. So now we're looking at B and D. Let's go a little further down in the code. So while something, we're going to do something. Okay. So let's think about exactly what the question is saying. So it's asking us to shift everything over by M places. So we're kind of going through the entire array and changing each element by shifting it over, and we're setting it equal to whatever is in the array 2 spaces to the right, because again, we're shifting everything to the left by M places. So for example, if we have this is just a quick example of 2, 3, 7. Right? So if we're shifting everything by 2, let's say we're at the first index at 2. If we're shifting everything by, let's say, M equals 2, then eventually this is going to be equal to 7, because the 7 right here is going to be shifted over twice. Okay. So let's think about let's think about that as we go along. So we have index is less than min. That's the same for both. And the difference is starting at this while loop here, where option B says while j is not equal to P plus index mod M, but option D is telling us P plus index minus M mod P. Okay. So the answer here would be D, because this entire algorithm, it relies on shifting everything over by M elements. So our inner while loop has to have a has to keep track and has to have an like exit case where we have m somewhere in there, because everything of the algorithm relies on the amount that we shift over by. So option B would not yield the right result because we're not keeping track of m as we go through everything. So, if we look at option D here, so let's say we have while j is not equal to p plus index minus m mod p. And then afterwards, we are incrementing j by m mod p. So there, the mod p after everything is just ensuring that rather than going past the end index of the array, we're gonna kind of cycle back to the front. It's kind of a little math trick to make sure that anytime we go past an array, we end up just cycling back to the front. And then again, at the very last part here, so essentially what this is doing, assuming the code with D, is we're keeping track of a temporary variable at the current index. So let's say we're at here. And then we're going to shift everything over by 2, right? So eventually this will have equal 7, and then this will equal 1, and then this will equal 9, etc. But by doing so, we need also to keep track of the current variable 2, and then eventually insert that here. Just like if we swap 2 elements in an array where we need to keep track of the temporary so that eventually we could replace it after, that's kind of what's happening here, where instead of just once, we're doing that within a loop. So we're going to swap everything over, or not swap, we're going to shift everything over by 2. But then we also need to keep track of that 2, because at the very end, after this array ends, we want to insert that 2 back into over here. And in order to do so, we need to keep track of the index minus m here within the initial while case right up here. So because of that, we can eliminate B and have D as our final answer. Okay, so let's move on to question 6. Let a class soccer be a friend of class racket. And let class tennis be a child class of racket, and let football be a child class of soccer. Which one is false? Okay, so let's just draw out what exactly is happening here to make it look better. So we have soccer, and then that is a friend class of class racket. So we can write this as kind of using this of class racket, and then let tennis be a child of racket. So we can illustrate that by saying this, and we'll just have a child class. So tennis is a subclass of racket, and football is a subclass of soccer. So let's also write that. Okay. So soccer and racket are friends. Okay, so they're related by inheritance, which also means that because of the rules of inheritance, like within object-oriented programming languages, the inheritance gets passed down to all the subclasses as well. So in this case, because racket and soccer are related by inheritance, it's calling them friends in this case, but really it's just basic inheritance. We can also establish this connection here. And then similarly, we can do the same for football and racket. So these are also, due to the rules of inheritance, football and racket are friends too. So this is a kind of a basic diagram of this relationship here. So with that in mind, let's go through these questions. So A, racket is not a friend of soccer. I mean, that is true. They are friends. It even says it in the prompt. So this is true, which means this can't be it. Soccer is not a friend of tennis. And like we said just now, because of inheritance, the inheritance gets passed down through subclasses. So these two are related in that sense. So this is, soccer is a friend of tennis. So this can't be it. And then same thing here. Football is not a friend of racket, just like the other one. The inheritance gets passed down the other way as well. So it can't be C, which leaves D as a final answer. Football is a friend of tennis. The inheritance does not apply for both subclasses, only within the subclass and then the parent class. So football is a friend of tennis. That is false. Football is not a friend of tennis. So D is our final answer here. All right, let's move to 7. Consider the following code. So we have a class called MHO, which has has 2 constructor methods and then 1 assignment method. And if you remember what an assignment method is, it's a method that allows us to perform basic operations on a class. So in this case, this is the minus operation. And then so we have a basic no constructor here, and then we have or no parameter instruction here, and then this constructor takes in another object of type self. Okay, so let's figure out what the output will be. So there's 2 lines of code happening here. There's creating MHO, which is just creating a basic variable here, and then we're performing a minus operand on the second line. So let's take this step by step. So the first one here is just creating MHO, and that's it. So that's just going to hit the first constructor here because it's void. There's nothing, it's not being passed anything. So the first thing it'll print out is there it was. So now we're going to hit the second part here, A equals A minus A. And this will trigger this operator right here. So let's go down what's happening here. So it's going to take in another MHOY. And in doing so, behind the scenes, what's happening here is it is actually going to be evoking the second constructor here because we're passing in Y as another MHO, it's going to pass down, it's going to hit the constructor that takes in another type class by reference. So once we hit this, the first thing it's going to do, it's going to hit this second constructor right here and print out this print statement here. Okay, and this is all before it even hits this line. So it's going to hit that. And now we're going to hit this line right here, which is, again, just like the over here in main, it's going to create a basic class or a basic object of MHO. And that, again, that's going to hit this null parameter constructor, which is just there was. All right. And then it's going to return that, and that's not going to see out anything. So the total output will be this string right here, which is going to be D. All right, question 8. Sam has received marks of n number of subjects after his school exam, and the marks have been stored in an array from A1 minus n as A1 to all the way to n. His father wants to know the summation of marks of the first subject and the last subject. Now help Sam to maximize the summation value by rotating the marks by 1 position to the right side. For example, if the marks are 1, 2, 3, it'll give 3, 1, 2, and then again 2, 3, 1. So essentially what's happening, what concise algorithm that Sam here is attempting to do is, let's say we had an array again like this. And let's just give it some random values. So 7, 2, 8, let's do 4, 9. Okay, so you have an array here, and his algorithm here is To calculate the first last subject, he's essentially just going to rotate the array by 1 each time. So he's going to rotate to the right, and then he's going to maximize, find the maximize of a1 plus an. So the first one and then the last one. And then he wants to find what is the maximum pairing of that. So essentially what he's doing is just finding the maximum of two pairs that are two pairs that are next to each other, because that is in a way finding, because as long as you're rotating the entire way, it's going to end up finding the maximum of the first and last one. So let's look at the code here. So most of the starter code looks like is just gathering the info. He's allocating the array and then filling the array. So for I0 to length. So we have two cases here. We have if I is not at len minus 1. So if I is not at the very end, which is len minus 1, then we're going to add up I and I plus 1. So like 7 or plus 2 or 2 plus 8 or 8 plus 4. Okay, and it's gonna find the max of that. And then else some code goes here. So what is that else value? Well, it says here if I is not at the last element, then we do that, because if we do that, as long as I is not the last one, we can just calculate I and then the I of the index after. But if we hit the length minus 1 and try that, it's going to hit an index out of bounds. So in this else case here, we want to account for the case where I is at that last index. And if that's the case, then instead of doing I and I plus 1, we want I and then circle back to the first index. So it'll be I and then array at 0. So looking at these options here, we can see that A does exactly that, where if array at I and array at 0 is greater than max val, then we want to max val is just the addition of those two. So again, there's two cases happening here. There's if I is not at the end, which allows us to calculate like 7-2 or 2a, or just, any two adjacent numbers. And then the edge case here is if I is at the end, then instead of doing that, we want to do that last index and then circle back to index 0. So answer here is A. Going on to question 9 here, Akash has been given an array of size n-1. This array has distinct integers only in the range of 1 to n, and he's been asked to find the missing element where the input is n and n-1 integers. So a key thing to keep in mind is the array size is n-1. Okay, so it's pretty small program here where he just gets the length of the array, he allocates the array, and then it looks like he's just finding the sum of all that. And then it looks like at the very end, he's using a neat little trick to find the missing value by like using the summation algorithm in math to figure out what that missing value is. That's what's happening on this printf. And the question is asking us for this line in red, which of the following is which of the following option is always true? Okay, so remember, and the reason, if you remember just now, I said keep in mind that n-1, right? So the array is not size n, it's size n-1. So because of that, when he allocates the memory for that array, he needs to also adhere to that, because otherwise it's going to end up with some sort of error. So because he wants the array of size n-1, the memory allocation of that array needs to follow that too. So in this case, he put len times size of int. So this is fine here. This is fine here. But the length should also be side of length -1. So here we have B as the answer. Okay, so last question here. Principal of previous school has given her an array A of positive integers representing numbers of marks obtained by students in the exam, and to discover all those leader students. And the leader student is defined as if his or her mark is greater than or equal to all the elements to the right side. So again, we have an array, and a leader student is defined as if a number in that array is greater than all of the numbers to the right of that array. So this is the code that she's written for that. And the question is, on the background, which of the following option is always true? Okay, so let's go through this for loops to see what's happening here. So we have the for loop here, the outer for loop, just going through each index of the array. And then we're setting a flag. And then for each index of the array, we want to check if that student is a leader. And it looks like they do that by having another inner for loop that begins at that I all the way to length -1, and it checks every number in that array after that I to see if there's anything, if that student is a student leader. And remember, it's a leader if everything on the right side of that array is less than the current number. So looks like they do that here by saying if array at I is greater than array at J, then we set the flag. And then otherwise, if it's not so, then we would detected that it is not a student leader, and then we set the flag as 0. So like this is looking good because this is going to work as intended, because we only want to break when we found a case where it's not a student leader. Because as soon as we found that's not a student leader, then the values after that don't really matter, because all we need to know is true or false. Is that number at that index a leader? So we break here as soon as we find that. So looking back at the questions, the answer here will be B. The break statement is placed because again, we sift through every single element in the array, and then for each element, we want to go through again, looking at everything to the right side and determine if every number on the right side is indeed less than the current number. And as soon as we find any instance of that, we want to flag it as 0 and then just break, because again, everything after that doesn't matter anymore. So with that in mind, we have the break statement as it is placed right. So we have B as our final answer. Okay, well, that concludes the question set for this week. Again, this is where you can check us out on the website, and we will also be regularly uploading all these explanations to the YouTube if you want to review again.